Here is yesterday's homework. Kind of a bonus. If you watch the video, you'll get this. Um, and make sure you have the assignment correct at least. So we were just simplifying with the natural number e. So the rule for multiplying with the same base here is is e for both of them, is to add the exponents. So it's e to the 3 plus 5, or 8. Problem 2. We can simplify 11 over 22. That's 1/2. When we divide, we do e to the 9 and we do minus 10. Now notice I put that in the numerator because that's what the property says. This comes out to e to the negative 1 over 2. Now we don't like negative 1 or negative exponents in our final answer, so we're going to move that e to the denominator using its reciprocal. So what it does is it leaves, there's a 1 up here. You got to have something on top in your numerator. But this will become e to the first power then. Ultimately, I think this problem is much easier to understand if you just understand how exponents work. So let's take a look at this one in a different way so it maybe makes more sense to you. 11 over 22 is still a half, but this is how you deal with the variables here. It's e to the 9th. These are all e's multiplied together. Here's 10 of them multiplied together. So every time you get an e over e, they simplify to just 1, or they cancel each other out. So there's 9 up here, and they will cancel with 9 of them in the denominator, leaving you that extra 1e, which is the extra e that you have in your answer. So instead of doing the 9 minus 10, I did the 10 minus 9 essentially. But if I do the 10 minus 9, my answer would go in the denominator. Problem number 3 here. Okay, we've got to raise each factor inside to the 4th power. We can figure out what 5 to the 4th is. That's 625. E to the, and the rule is when you have a power to a power is you multiply those. Well, 7x times 4 is 28x. Number 4, showing all the steps, I would think of this as the square root of 9 times the square root of e to the 6x. The square root of 9 is 3. I'm going to write e to the 6x as e to the 3x squared. The 3x times 2 is 6x. But by writing this 6x as 3x times 2, I can now take the square root of a perfect square. And so the square root of a perfect square, they just undo each other, giving you the following: 3 times e to the 3x. So the square root of something squared, giving you just e to the 3x, giving you 3e 3x. Now the only way to do it, you could do it this way. Up here I still separated, this is 3, and then I could think of e to the 6x as e to the 6x to the 1/2 power, because a half power means to square root it, in which case I get 3, and here's the product property, or the multiplication, power to a power. 6x times a half is 3x. So you get the same answer either way you do it. Finally, number 5, these are all the common bases, same base e, so it's just e to the x plus negative 6x plus 8. Just add all the exponents together. We have like terms right here, that's negative 5x plus 8, and we're done. On to the new material. 6.2b, the natural base e, we are just continuing what we were talking about yesterday. Remember, this E value is equal to approximately 2.72, and it's just a constant that we use uh, in our mathematics, especially when talking about growth and decay functions, exponential growth and decay. So just real quick review here. If you recall, f of x equals b to the x, this is an exponential function. Okay, there's our x value, and there's some limits on b. Remember, b had to be greater than 0, and it can't equal 1. And then we said, well, it falls into two groups, these exponential functions. The exponential growth group, so if b, the base, is bigger than 1, it's going to be exponential growth. If it is a fraction between 0 and 1, it'll be exponential decay. Now, it turns frequently out that the base for this function, remember, could be any number greater than 0, but frequently we'll use e as a base, the natural number. So this is the basic form for a exponential or a natural base exponential function. It's called the natural base exponential because here's your base e because your exponents are right above it. Okay, so the a is not part of the base, just the e is the base. The a would be called the coefficient, and the r and the x are both exponents. So our base e functions, now e, you have to remember, it's about 2.72. So it's going to be a growth function if it just has e in it. But then there's some games we can play with the exponent here to put that e in the denominator, and you'll see that in just a moment. But regardless, once we get the e into the denominator, it does become a decay problem. So exponential growth, if you're doing a base e function, if the a value and the r value, if they're both positive, then it's going to be growth. If a is positive, but if the r is negative, less than 0, it's going to be decay. So the big thing, really, a is greater than 0, that's just something that has to be said, otherwise you get reflections. And it's not growth or decay at that point. So your a has to be positive. So really, you just want to focus on the exponent. And what they're just saying here, buddy, is that like if we have e to the first power, that is, about 2.72. But if you did e to a negative exponent, it becomes 1 over e, which is 1 divided by 2.72. And see, now we get a decimal value. We get a number that's greater than 0, but less than 1. And so you get that decay function because your base is going to end up being this little decimal. So we've got these two types of functions, the same types we had before for our exponentials, except now our base is an e. Let's go ahead and look at graphing the natural base exponential here. We're going to add in, hopefully, and we'll see how this works. And let's go to Desmos. So let's take a look at the base function. You're going to have to be able to do this on your calculators. So using Desmos, I'm just going to graph this guy. For f of x, I can use y equals, and I got to find my base e. And I'm not quite sure how it does it, so we're going to try e. It did do it. Very awesome. Hopefully you can see up there in the equation editor that I just put in the letter e, and it does go as e to the x. So there's your graph. And then to draw this on paper, it's going to be relatively easy, or at least to not draw it. Today you just have to be able to pick it out of a lineup. Okay, so when you're trying to pick it out of the lineup in Desmos, what you want to do is look for these key points. So 0, 1's a key point, and then just kind of run your finger along it until you find another good point. Now, what you're going to find in these things is that it's very tough to get any solid points. So what you want to do is look at your x values, and when it gets to a nice whole x value, like right there is at 1, so just get as close as you can. So 1 and 2.7. So if I was going to graph this thing by hand, I know when x is 0, it went through 1. And when x is 1, it went through 2.7. Now, this shouldn't be a surprise because this is e to the x that we're doing, so it's e to the first power, which is about 2.72. When we try to get any other values for this, we do squared, that's just e squared. We can do some negatives, negative 1, e to the negative 1, which is 1 divided by e. But at this point, everything becomes a calculator problem. So we just kind of can skip the calculator if you use Desmos. Okay, you don't have to get a ton of points for something like this. A good point to get would be that 1 and then that e to the 7. In fact, those two x values and sometimes negative 1 are going to be the key for all of these. Let's take a look at another one. Let me get that out of the way. So this is now e to the negative x. We know it's going to be decay. Let's just make a little table of values here, x and y, and we can go negative 2, negative 1, 0, 1, 2. It's going to become a positive 2 because you'll have negative 2 to the negative, or times the negative. This will be e to the positive 1. This will be e to the 0, e to the first, and e to the second. So we know this is 1, this is e, approximately 2.72. We'd have to get a calculator out. Should be e to the negative 1 right here. Should be e to the negative 2. 1 over 2.72 and 1 over 2.72 squared. So it's pretty tough to graph, obviously. And you would have to get a calculator, but we know at 0 we're at 1. At 1, we're at 1 over 2.72. That's, a little bit less than a half, somewhere in that neighborhood. So it's doing this. Then when x is negative 1, it went up to 2.72. It's about right there. And at negative 2, 2.72 squared is just something higher. I'm not even going to guesstimate where it's at because I'm going to know what the shape looks like. So there's only a couple, 2 or 3 points that we need to get in there just so we have a decent idea that, hey, I do know it goes through 0, 1, and it looks like negative 1 goes through approximately e, 2.72. Let's do another one. I'm going to do this one first by hand just to show you how you can calculate these values. Then we'll get out Desmos because that's how most of us will attack it. So negative 2, negative 1, 0, 1, and 2. I'm just filling these all in. So with that negative exponent, that e, the natural number, is going to need to be in the denominator as a positive 2 exponent. This e to the negative 1 will go to the denominator, and it's e to the first. E to the 0 is just 1, so it's just a half. This will be half of e, or e divided by 2. And this will be an e squared divided by 2. So you'd have to be very careful here to get out your calculator and evaluate some of these things. The half is easy, so 0 half. It's going to be easy to divide e by 2, 2.72 divided by 2. Uh, just be careful when you're doing these probably. Um, if you do this on your calculator, you'd have to go 1 divided by, you'd have to put the 2e in parentheses to make sure you divided by the entire 2e. Now, since you'd have to get a calculator out to get these values anyway, I think it's going to be more important for you to be able to use Desmos to graph it and pick uh, the points that are important. So let's graph this guy in Desmos here to make sure you guys know how to do it. So y equals 1 divided by 2 is how we enter that. 1 divided by 2. Then you have to arrow to the right so you're not in the fraction area anymore. You're not in that denominator. To pull up the e, just go to the alphabet, and there's e. You can see above the right by the equation, it has said the value of uh, what's inside there. Half times e is 1.35, half of 2.7. Back to our equation, to the x power, so I hit the a to the b button, and I put an x in there. And so there's my function. And now let's find some good points. So when x is 0, there's our 0.5. Let's trace him now to see if we can find what happens when x is 1. So 1 gives us that 1.35. That would be a good point. 2, close enough. 2 gives us about 3.7. So those would be a couple of points you could put into a graph if you had to do it by hand. See if we have any tougher ones. Let's see how this one looks when we do it in Desmos. And that's that's exactly where I would start all of these problems. So we've got y equals 4. Let's pull up e to the. That's got that negative x in there, so this is going to be decay because that's the r essentially in front of it. Let's take a look at, oops, back up. There we go. So there's my decay function. If I wanted to get a few points for this or from this, notice what happened here. There's his y-intercept. Now it's at 0, 4. That's because of this 4 that is a coefficient out front. So when you do the f of 0, you get 4 times e to the negative 0 power, which is 4 times e to the 0, but anything to the 0 power is 1, so it's 4 times 1, or 4. So that's where that 0, 4 comes from. Again, I said it was decay, and I knew that because this value in front of the x was a negative 1. If we go to the right here, maybe we can find, hopefully, there we go. Maybe we can find another decent point on the right. We'd go down to -1, or +1 rather. Not really going down to it, I'm going over to it. So there we go, 1, it gave us about 1.4 at 1. Decent value. On the left-hand side, you'd probably have to rezoom it. Still have to rezoom. I'm just trying to get to -1 here. So at -1, it looks like it's about 11. And that'd be it. So your homework, that one should be pretty straightforward to enter. Your homework today, everybody, is a Google form. It's going to ask you if it is growth or decay. Um, And then it'll ask you to pick the graph out of 4 graphs. So you're going to have to pull up Desmos, take a look at it. There are on each graph, you'll see a point that is points that are marked for you. So you just got to find the graph based on the equation that matches